In lesson 7, we are going to analyze the set of points that are the same distance from a given point and a given line. So this starts on page 52 with a notice and wonder. So go ahead and look at the image there, write down a couple of things that you're noticing and wondering, and then come back to the video. So again, with it, like every notice and wonder, you could notice a bunch of things. This is just a couple that you might have looked at, not an exhaustive list. So maybe you notice that there's a central point F and there's a lot of other points. And then you see some other points here. It appears that these dotted lines are connecting each point to this horizontal line and to F. And it looks like the points, if you were to connect them, would make a smooth curve. Some things you might have wondered. Are the segments that go from each point equal? So is this segment equal in length to this one? Is this one equal in length to this one? And so on. If we added in more points, would they fall on that same curve? And is that curve a parabola? So maybe those are a couple of things that you thought about. So let's take a look here at some vocabulary. So have we seen a curve like this before, where when you connect these points, so that curve is called a parabola. And then we have what's called, probably new language to you, a focus, which is that F point, and we have a directrix line. Okay, so a focus and a directrix. So the focus is kind of on the inside of that curve, and then the directrix is a line outside of that curve. So the parabola is going between those. All right, then on page 53 in your book, let's take a look at these images. So first thing I want you to do is highlight the directrix in each image. And then I would like you to highlight the focus. So the directrix in each image here is the x-axis. So just highlight that. And then highlight the focus, that point F on each image. And then I'd like you to determine how far is the focus from the directrix. So how far is the distance between the focus and the directrix, and how does that change these parabolas? So if you take a look here, like let's just come up with the distance. So here's the focus up here at y equals 1. And then the directrix is at y equals 0. So this distance here is 1. The distance here, we're at 3 of a height to 0. So the distance here is 3. 5, 2, 5, and then 2. So what is that change in distance from the focus to the directrix doing to the parabola is what you're looking at in this number 1. Okay, so how is that affecting the shape of the parabola? So it appears that the, further the focus is from the directrix, it's impacting the width of this curve. So this one was only 1 unit away, and this appears to be a pretty skinny curve. This one was 3 units away, and the curve got wider. This one was 5 units away, and the curve got wider. This one also, the focus is below the directrix, and so the parabola opened downward. Same here, below, 2 units below, and the curve opened downward. So it seems, so what seems to need to be true in order for the parabola to open downward? Okay, that the focus needs to be below the directrix. And the distance between impacted the kind of width of the curve, or the width of the parabola. The vertex of the parabola is the lowest point on the curve if the curve opens upward. Okay, so if we're talking about the vertex on the parabola, the vertex is here, that lowest point if the curve is opening up, and it's the highest point if the curve is opening down. So if we kind of highlight the vertex on each of these curves, okay, you can see it in your book. It's got a dot there. Where is the vertex located in relationship to the focus and the vertex? So the focus and the directrix, where is that vertex located? And it appears like it's in the middle or in between. So between the focus and the directrix. And then if we take a look here, we notice on the final image that there is a point labeled. So what is the distance between the point and the directrix? So the distance between point P and the directrix. And remember, the directrix is the line y equals 0, or the x-axis. So here's your directrix. How far is point P from that line? And so remember, we would just drop a vertical line to a horizontal to count the distance. So then just figure out that distance. You can either count how far it is, since we've got grid lines. We also see that this height is at 5 and the directrix is at 0. So we know that that distance is 5. And then what does this tell you about the distance from P to F? So from what we were looking at in the notice and wonder, we said, well, we think that that makes it the same distance to F, because these points on the curve, when we connected F to the point and the point to the horizontal, they appeared to be the same length. So let's take a look and see if they really are. So we could draw a triangle here. And then we would be able to do Pythagorean theorem. So if we count this is a height of 3 and a width of 4. And if we quick do the Pythagorean theorem, 3 squared plus 4 squared should equal that distance squared. So 9 plus 16 is 25. Square root that, and we end up with 5 here as well. So we could maybe just guess that it was the same, and then you can actually also confirm there that it is the same distance. So P to F and P to the directrix are both 5 units. So looking again just at that image and kind of re-talking about this, so the location of the focus and the directrix. So our focus is the point. And actually this is a new image, sorry. So this one is not in your book, but let's take a look at it. So the focus is at the point 4, 5. So this point right here is the point 4, 5. The directrix in this case is no longer the x-axis here. Okay, it's actually at the line y equals 1. And then the vertex, this says, is a special point on the parabola. Okay, how can we use distances to describe how it's unique? So if we take a look here, the distance from the focus, and we kind of said this before, is it was in between. So let's look if it's actually directly in the middle. And so we see that this distance is 2 units. And here's the directrix up to the focus. That's also 2 units. So this vertex is directly in between or in the middle of those two points, or of the point and the directrix. And the vertex is the 0.43 in this case. What's the distance from B to the directrix? So on this one, here's B, okay, to the directrix would be down, okay, so straight down to the directrix, and we could count that again, or we could look at the height of this is 7.5, and again, this is at y equals 1, so 7.5 minus 1 would get us 6.5 units away. So what do we then know about B to the focus? And since any point on this parabola is the same distance from the directrix as it is from the focus, we would know that this distance is actually 6.5 as well. And then how could we verify that? So we could verify it by doing the Pythagorean theorem. And so let me get some of the rest of this stuff away from here. And so we could draw in a right triangle to get us to connect the point to the focus. And then we would want to calculate these distances here. Now remember, the focus is the 0.45. So when we go to calculate this horizontal length of the triangle, remember the width of the triangle subtracts the x coordinates. So we can do 10 minus 4 here. You can also count it. And then to get the height of the triangle, we would look at the y values. So 7.5 minus 5. And we would get 2.5 for that height. And again, you could count it, but it's halfway up. But you could get 1, 2.5. So then you could do the Pythagorean theorem there for that right triangle. So let me just draw it down here. So we got the width was 6 and the height was 2.5. So then you could calculate and do the distance squared is equal to the legs squared and added together. Just do your Pythagorean theorem. So this is 36 plus 6.25. So we get 42.25, and then square root that, and you get 6.5 when you do the square root of 42.25. So we do get that the distance is the same as what we got for the focus to the directrix. All right, so let's test a couple of points here and decide if they are on the parabola and verify that they are. So remember that they should be the same distance to the directrix as they are to the focus. So the directrix you should be able to count or subtract your y value. So we should be able to either just count it or look. So this directrix here is at y equals 0, the x-axis. So this point is 5 units from the x-axis. Then you want to do your Pythagorean theorem to calculate the actual distance here. So connect and get your right triangle so that you can do your Pythagorean theorem. The coordinates of this focus are 6, 4. So we'll just count over 6, 4. So then when we go to find the width here, okay, subtract the x's. So 11 minus 6 gets us this width. The height here, 5 minus 4 gets us 1. So then we can do the Pythagorean theorem here to figure out the this length here from the focus to the point. So we get 25 plus 1. So d squared is equal to 26. So square root that, and you get that the distance is not equal to 5. Okay, it's equal to just over 5, so you get 5.1. So this one is not on the parabola. So then you can repeat that idea with the next point. So let me change colors here. So we can take a look at the distance to the directrix, so we know how far this needs to be on the parabola. So those two segments need to be the same length if it's on the parabola. So this one straight down to the directrix is 10 minus 0 because it's at y equals 0. So it's 10 units. So then we need to verify that this segment is also 10 units. So let's draw a right triangle connecting to the focus. Figure out the lengths there. So the width from 6 to 14, so subtract the x's and you get 8. The height, subtract the y's, so 10 minus 4 and you get 6. So here's that triangle, since it's kind of hard to see over there, but we've got a width of 8 and a height of 6. So now we're calculating that distance. So we get 8 squared plus 6 squared, and we want this to be 10. Okay, that distance from the directrix to the point. If it is, then this is on the circle. So 64 plus 36 is equal to 100. Square root that, and we get 10, which was this distance here. So 10 and 10 means that this is on the parabola. So yes, this one is. So in general, how could we do one with any point? Okay, so if we just had any point on the circle or on the parabola. So first we needed to calculate what the distance was to the directrix. Okay, so the distance to the directrix. So in this case, we did the y value minus the directrix y value. Okay, so the distance to the directrix was y because it just ends up being y minus 0. Then we need to verify that the segment connecting to the focus is equal to that distance. Okay, so with this one, figuring out the height and the width. So the height, we would subtract the y value. So this would be y minus 4. The width, we would subtract the x values, so x minus 6. And then this distance needs to be equal to the hypotenuse there. Okay, so that distance to the directrix. So we know that our distance to the directrix needs to equal these legs squared and added together. So it would need to work in this formula. All right, so imagine that we have a parabola with a focus of -1, 3, and you can draw a quick sketch of this. So -1, 3 would be here. A directrix, remember that's a line at y equals 1. Okay, so horizontal line at y equals 1. Where would the vertex be here? So remember that the vertex is directly between the focus and the directrix. Okay, and it's on the same x value. It's got this same x value, so it's right in between these on this kind of vertical line. So your vertex in this case would be right here. So remember that your focus was -1, 3. Okay, and then you had y equals 1. The y value right in between there is 2. So this vertex would be the ordered pair -1, 2. How far is the point 3,6 from the parabola's directrix? So if we go over here and plot the point 3,6, how far is this from the directrix? Remember, this is a y value of 1. This is a y value of 6. So it's going to be 6 minus 1, where the directrix is units away. And then how can you calculate the distance between any point and the directrix? Take the y value and subtract the directrix, okay, which in this case is 1. So this would get you any distance. And any distance between the focus, so x minus, or xy and the focus. So that's where we said the distance to the directrix then squared would have to equal the width of this triangle. So x minus, and now we're using the focus, -1 squared. The height of that triangle would be subtracting the y values and squaring them. So using Pythagorean theorem and then knowing that the distance has to be the same as how far it is from the directrix. So kind of similar using Pythagorean theorem with a circle. With a circle, we used the center point. Here we're using the focus. So this can go on your reference chart. And then here's a summary. So the set of all points that are the same distance from a given point form a parabola. So this curve is the parabola. That given point is called the focus. And the line is the directrix. So any point on this parabola, the distance from the point to the focus and the distance from the point to the directrix are equal. So these two green lines are equal, and that would happen throughout. And you could draw another, like if I did another point on the parabola, if I went to any point and then went directly to the directrix, those lines would be equal. So those pink lines are equal, these green lines are equal, etc. And then we can test if a point is on the parabola by figuring out how far it is from the directrix and then creating a right triangle here, knowing that this hypotenuse distance is the same as the distance to the directrix. So figuring out the height by subtracting the y's, the width by subtracting the x's, and then doing Pythagorean theorem with the distance here being the same as this distance here. And then this is your cool down. So go ahead and try this. If you're struggling at all, be sure that you reach out to your teacher.